down in Carlsbad. So JR, we'll go ahead and turn it over to you for discussion.
Okay, thank you. I have a presentation that's being projected onto the wall here. It may be a little difficult to see, so as I go through the presentation, if you have questions, get my attention and we'll address them at that time. I'm J.R. Stroble. I'm part of the Department of Energy's Carlsbad Field Office. I've been there at WIPP for 24 years. And I lead the group that is responsible for interfacing with all the sites that have true waste that want to get them to WIPP. And this setback that we've had in our program, although it's been disappointing, it's taught us a few new things. And as we recover the repository, we're going to incorporate as many of those lessons as we can in what we've learned. And we've also learned a lot of things with LANL. We've been working closely with LANL ever since the WIPP had its issues, and we've learned a lot of things, and I still think there's some things left to learn, but we've learned enough to this point that we have a lot of plans for improvement. So today I'd like to provide you an update on where we're at with recovering the WIPP repository. And so, like I said, if you have questions along the way, feel free to get my attention. We had 2 incidents earlier this year in February that caused us to shut down our operation. The first one was on February the 5th. We had a fire down in our underground mine. It was on one of our salt haul trucks, and fortunately, everyone got out of the mine safe, but it did leave a lot of soot. It did put into question our emergency operating procedures and our ability to respond to such an emergency. So we were down, at least in the repository, on February the 14th when we sensed a release of radiation from the active disposal panel down in the mine. The ventilation system was active at the time in which we were operating and did its job. It detected the radiation and switched to high efficiency filtration and kept or contained most of the particulate that had been released from room 7 of panel 7 down in the repository. We've learned a lot about what happened in that room that evening, but we haven't learned everything. And so the Accident Investigation Board, who was tasked to independently evaluate what occurred, is still ongoing with that investigation and hopes to wrap it up soon. They had hoped to wrap it up sooner, but as most things go, the more you learn, the longer it takes to wrap it up. So if it goes well, maybe before the Christmas holiday, they'll finalize that report, but it very well could run into January. We just don't know yet. Here on the left is a picture of the salt haul truck and the tire that created most of the soot. It was actually a hydraulic or a flammable liquid fire that started it, but created the mess when the big rubber tire went up with it. Over here is the one container we've identified to date that's in room 7 of panel 7 that appears to be opened and appears to have released some of its contents. It also appears to have produced a lot of heat inside that container, because these containers, this particular one came from Los Alamos. When it went into the repository, it was painted white and the lid was closed. The white stuff on the top is magnesium oxide, which is placed in the repository on top of the stacks as the waste is in place for long-term repository performance purposes. We might have been fortunate that it was there because that product also happens to be one of the products in fire suppression systems that are used. But that wasn't its original purpose for being in there. So on February the 5th, the salt haul truck was in this portion of the mine. These are the shafts that are going to and from the surface. The mine's about 2,100 feet below the Earth's surface. It's basically just alleyways that are carved out of a big salt formation. Over here on February 14th is where the continuous air monitor was located when it sensed the release of radiation that appeared to come from the drone that was sitting in this area, which is the first room to be filled in panel 7. This picture up here, I know it's kind of hard to see on this wall, is one of the first still shots of a video that we took with a boom that was over the waste stack. And that's when we started seeing pictures of the magnesium oxide piles on top of the waste containers. These originally were placed in here in plastic bags, and the plastic bags were gone, so we knew that there was a lot of heat that had been produced in that room to melt those bags. This is a 3D depiction of the waste that is placed in room 7 of panel 7. The stacking started over here, and we went this way. We got 24 rows of waste in before this incident occurred. And the one drum that you saw in the previous picture is located on the top of the stack under this magnesium oxide bag right there. The orange-colored magnesium oxide bags are bags that appear to have been exposed to the high heat. They have either bags that are gone or that are partially damaged due to heat. The other bags on tops of the stacks do not appear to be damaged at this time. The red containers that you can kind of see in the graphic are containers that contain either all or a portion of the same waste stream that the one container from Los Alamos that did show to be breached came from. You probably know it today or have heard several times over the last several months that we generically refer to that waste stream as the nitrate salts waste stream. And it is nitrate salt that was solidified and that has a high concentration of americium and plutonium in it. And those are particulate radionuclides. And so when the container heated up, the lid popped up, the contents came out. It appeared to have happened under a high heat environment. All of those airborne particulates got into the air, into that room, which is ventilated, and it was pushed through the exhaust portion of the mine into the HEPA filtration system. So one of the things that we want to know about that room, since we haven't been able to reach all the way back into the first row, is are there any other containers like that we would be able to see from a camera hanging or dangling from above? We were only able to reach back about 10 rows. We want to be able to reach back all 24 rows. So we've been developing a boom system that is arrived and is ready to go underground. And this boom system is a engineered boom that deflects very little when a camera is placed on the end of it. And this trolley system will be able to place it in front of the waste stack and reach out over the waste with a camera on the end and be able to basically map the whole room with video and still shot objective evidence for the Accident Investigation Board. We'll also have the ability somewhat to drop the cameras down, but we're not going to have the ability to disturb any of the waste. And so we hope that this mapping will give us a good answer on were there any other concerns with the waste in that room.
JR?
Yes.
When are you supposed to have this system totally operational?
It's on site. It's been tested in a surface facility. The pieces of it are being transported underground, but that's a limited movement. And as soon as we can dedicate a forklift to this operation and we can get this trolley system built in the room, then we'll get going on it. Right now, the projection is that we'll be able to take pictures from the end of that boom probably on January the 5th of the coming year. We've learned a lot of things since the two incidents. What we learned is we had weaknesses in some of our programs, and we are undergoing a cultural change with a lot of those systems, especially in the world of nuclear waste management and conduct of operations. And we're going to reemphasize safety in all areas, including nuclear safety along with it. The two accident investigation reports that have come out so far, one being from the fire, the other one being from the first phase of the radiological release, revealed several weaknesses, and we are working on the corrective actions for those right now, have been for several months, and we've incorporated some of them and have resumed going underground on a daily basis in the last month or so. It's a limited trip each time we go, though, because the underground facility is contaminated. At least parts of it are, and I'll have a map. I'll show you those parts in a minute. And it's being done under a what I would call an interim safety basis document that's been rewritten for this recovery operation. So the basic steps of recovery are radiological rollback, where we go into the repository and we define where the contamination is, and we define where the clean areas are and the not so clean areas are. Reestablishing of the safety systems and cleanup and making it a habitable environment again. Restoring our fire protection systems and performing maintenance on the geology down there. A salt repository is a living and active organism, and it moves and wants to seal itself up over time, and when we're in there operating it, keeping it open for waste emplacement, we have to do a lot of things to keep it open and keep it safe, including putting in rock bolts to keep any fractured rock from falling or coming in on any of our workers or any of our equipment. So expediting the mine stability and resuming bolting now that we're down in the repository again is our number one priority, and that's been occurring now for about a week. Also, a priority for us is the expediting of the closing of panels 6 and 7, or at least room 7 of panel 7. We had not closed panel 6 yet, even though it had been filled when these incidents occurred. And we have an order from the state of New Mexico that orders us to proceed with those closures. And we have a plan that's been approved to do that. And we have started working those plans. Probably the next big feature we're going to want to add to the underground system will be interim and a supplemental ventilation system. Right now, our two limitations in working in the underground environment are the number of people that we can have down there because of our egress system, and because of the amount of fresh air that we can flow through the mine, all that air has to go through the HEPA filters on the surface. So HEPA filters are not designed for high air flows, and so we're limited in what we can do there. So we're going to put in an interim ventilation system and a supplemental ventilation system to produce more air in the areas of the mines so that we can do more rock bolting and we can do more reach projects. And hopefully by the first part of 2016, starting to get back into putting some waste down in the mine, but it'll be at a slow rate. So along with the restarting of the facility, we're also going to have to go through another operational readiness review. And in the meantime, that's limited a lot of the operations on site and with the generator sites. Although most generator sites are continuing to characterize and certify waste and store it, they have storage limitations and funding challenges while we're in a continuing resolution. And then I'm sure you'll hear more about Los Alamos's plans to recover their operation and get back into the certifying of true waste in their program a little bit later. So here's a plan view of the mine. I apologize for the quality of this, but in general, hopefully you can see the colors. The green areas are areas that have been determined to be clean, and workers can go in those areas without having any special protection, although all of our workers now underground are trained in radiological safety, and so they know what the requirements are for working in an environment like that. And so that'll be normal operation for us now. The red areas.
Excuse me, JR.
Yes.
So they will be suited up from now on?
Not necessarily.
Okay.
In the green areas, they don't have to be suited up.
Okay.
But if contamination is detected, they have methods for either getting out clean or suiting up and continuing with what they're doing.
So you have suit stations?
Yes. We have stations staged all along the way, especially between the transitions between the colors,
Okay.
for people to suit up if necessary, along with respirators.
Thank you.
So the red area is what we call the high contamination area. It was the area that the contamination spread to. Basically all of panel 7 and most of the ancillary drifts around panel 7. The blue area is the prohibited areas. That's where most of the contamination is contained, and that happens to be the exhaust ventilation circuit. So the ventilation system worked the way it was designed. The fresh air gets sucked into the mine from the shafts, which are all in this area, gets directed down to the panels where the waste is in place, and then out of the mine. And when the radiation was detected, it switched over to the filtration system so that the airborne particulates were not released into the environment on the surface. Yes?
JR, you just answered my question. Okay, so in the red areas that are deemed a hot zone, now the drum was ruptured in the drift. I believe that's what they're called, correct? Or is it the panel?
The drift is one of the access ways to or from a panel.
Okay, so panel 7 then would have been the one closest to the main area? Okay, so it would be the furthest away then.
Right here is the spot in which the waste in room 7 of panel 7 is emplaced.
Okay.
And airflow basically was coming from this area, going that way. So the blue area downstream of the room is contaminated, and it's an area that's prohibited from people from going in. But because the airflow was so low, it also spread upstream into the rest of the panel.
So the blue areas then, those are the areas of contamination. Now the contamination, that's in a form of a particulate then?
Right, it's americium and plutonium particles that are either in the air or trapped on the salt walls or ceiling or floor.
Okay. Thank you, JR.
Yes.
JR, thank you. So again, I just want to go back a little bit. The interim ventilation will cover what area, if you can just point that out? No, go back to the map.
Okay.
And
Interim-
then- and then
interim
we'll
ventil-
just- And the supplemental will just go ahead. Is it going to be a redundant system eventually? And then it'll be the backup or redundant?
We've used the two different terms because they are two different things.
Okay.
So I'll cover each one of them.
Thank you.
The interim ventilation system basically will be HEPA filtered skids with fans that'll be installed on the surface right next to the existing HEPA filter banks. They'll be tapped into the main duct, and so they will pull additional air that's also filtered through the mine, because the limitation we have right now in our current filtered system is the size of the fans and the size of the filter bank. And that's about 60,000 cubic feet per minute of air that it can pull. With the interim ventilation, we hope to get around 115,000, and that'll give us some extra air to work with in the mine.
And so you're limited though because of your hotspots and your contaminated areas.
We are limited because of the hot spots, but I'll cover a little bit more on that too.
Okay.
Now, the supplemental ventilation system will be fans that'll be installed down in the mine that will bring in new sources of fresh air and provide fresh air to mainly the green areas, the areas that are not contaminated. And we can keep them under a positive pressure. That way, any contamination that's in the lower pressure won't want to travel to the higher pressure areas. It'll allow us to do more of a normal mine operation in those areas using diesel equipment where we have to have the airflow and not take away from the airflow that's required for working in the contaminated areas.
Okay, so that leads me to one more question. Thank you for bringing up the vehicle.
Okay.
A few of us were talking about that. Why is the vehicles, why are they preferred to be diesel? Are there not industrial strength electrical? I know there's some out of England, but I don't know if they would be available for this type of operation.
Some of our equipment is diesel, some is electric, and both types are available in this industry, and we've evaluated that on a case-by-case basis, and we still believe we have a need to operate diesel equipment because it provides greater power from a smaller source. The electrical feeds that we have going down into the mine just for the miner itself, which is electric, are tremendous power sources, and we'd have to drop additional new power sources down into the mine, which are all fed from the surface, in order to accommodate large new pieces of electric equipment. And our preference, we think the shorter path is to improve the ventilation system and stick with some diesel equipment. For example, the roof bolters.
Friendly pushback, though. The shorter path caused a major problem.
We understand that. We also don't think this is a shortcut. We just think that it was part of the evaluations that we're going to need to do from this point forward. In terms of worker safety and protection of the environment of the mine, all of that's considered when those decisions are made. And so electric, just because it's cleaner in its running operation does not necessarily mean that it's either safer or more efficient. And so those pieces of equipment are evaluated on a case-by-case basis. Take, for example, the roof bolter. There are electric roof bolters available in industry, but they're not as effective as a diesel roof bolter. Bolts break a lot more often with an electric bolter, and the hazard of dealing with the trailing cable and maneuvering that through the mine also increases your risk to the workers. We have that with our continuous miner, and it's one of our greater hazard risks in operating down in the mine is having those 14,800 volt cables being dragged around in a dirty salt environment. So our contractor is evaluating those on a case-by-case basis. We're providing the oversight on those evaluations, and they've made those decisions, at least for the interim operation, and we're going to keep challenging them to keep making those evaluations, because if a better, safer method comes along, then we're going to try to find them the funding to put that into place. Part of our additional funding request also is to buy new equipment so that we can prevent what happened with the salt haul truck. You know, that thing was old. We had band-aided it a lot, and we saw what happened from doing that. So we're going to do our best to bring equipment back up to new standards, and if we can't, we're going to replace it.
Yeah, okay, and then you would also schedule that new equipment, probably schedule it out as well, a little bit sooner than...
Would you repeat that, please?
I would hope that you would also, when you get new equipment, take a look at scheduling it out. And
Scheduling it out?
Yeah, not keeping it out, but keeping it down there as long.
Right. Yeah, if a piece of equipment has surpassed its safe working life, then we are going to access it.
Thank you.
The only other thing I wanted to mention on the map here is that the red areas, although they're currently contaminated, are some of the areas that we're going to work on cleaning up so that we can better operate in the waste disposal circuits. And one of those methods that we're going to use is I'm going to skip this one, is a fixative. It may just be simply water, which crusts real well when you spray it on salt and let it dry, or it may be some adhesive type fix-it. And we're going to do that everywhere we can to just fix it in place because we've determined that that's overall probably the best way to manage it. Some of it will be removed, but most of it will be probably fixed in place.
So, JR,
Yes.
is there still contamination emanating from that barrel right now?
From
the barrel that ruptured?
we have to assume that there is.
Okay.
We don't know that for sure because we don't have a detector right there on it,
So
but it's likely that it is.
when you close those panels, can you go back to that previous? Where would you close the panel? The one with highest contamination?
This is where the one drum is located. And so what we'll do is we'll put up metal bulkheads on each side of that area, and we'll shut off the ventilation to that area, and we'll put in what we call run-of-the-mine salt that's been mined out, that's clean in those areas to just fill in the void. And having it cut out of the ventilation circuit is going to be the primary protection method.
And the metal bulkhead is for explosions? Is that what?
Not necessarily. It's part of the sealing of the area off to keep the fresh air flow from going through. It's a metal bulkhead with rubber sealing panels around it, so it fits like a boot, and we can close those areas off completely, and keep fresh air from flowing through.
And once the two panels are closed, do you think it'll be safe to go back in some of these?
Well, it's going to be a limited operation. So the downstream side, we're going to do our best to keep people out of it, but we'll have people ready to suit up if they have to get in it. The upstream side, that's the parts we're going to try to clean so that we can finish using the rest of that panel because we don't want to waste that real estate. not only that, but it's going to take us a little while to finish mining panel 8 before, or when we get back into at least a light operation. And so we need a place to be able to dispose of the waste. So we're going to probably use the first 4 or 5 rooms of panel 7 until panel 8 is mined, and we can use that.
I just asked you about the red and the blue. Why a red area surrounded by blue? Wouldn't you assume that the highly contaminated area would spread throughout where we have that red area that's completely surrounded by a box of blue? Up
Right.
above.
Right now, the best way to look at this map is just a snapshot in time where measurements have been made by rad contacts that are fully suited up in respirators using instruments, and they've determined where contamination is and what the levels are. And so all that the red and the blue indicate are, they're both contaminated areas, is that the red is an area that we're going to go target for cleanup, and the blue is an area where we're going to keep people out of, and we're not planning on cleaning it up. Okay?
JR,
Yes.
I understand that there's a possibility of getting another exhaust shaft built. If so, where would that be located?
Yes, there is a plan for the future to drill a whole new exhaust ventilation shaft. It is a capital line item project that's planned for a couple of years from now. And the general area for that will be over here somewhere. But that's all part of that design that hasn't been submitted for approval yet. And then the drifts will be tied into that system. And then when we do that, then we'll have a clean ventilation exhaust drift, and we'll be able to get back into complete full new operations. So we'll be working with this contaminated, partially ventilated environment probably for a couple of years.
JR, you have
If you were to, after you're all done,
Go ahead.
what would happen if another barrel ruptured like this one? Do you have a way in place to somehow prevent the problem from getting as out of hand as it seems to have done here, to require this, 2-year response? I mean, somewhat in the sense like a ship has bulkheads, and if it gets a hole in one place, it closes it off so it can't get, the ship can still stay afloat. And in this case, is there something that would keep the mine so it could be operated even if another incident occurred, or it could be brought back online in a matter of months rather than years?
We have talked about several supplemental features to our underground ventilation system for that very reason. We've talked about localized HEPA filter skids. We've talked about remote operating bulkheads, and I think the remote operating bulkheads is going to win, and so that'll probably go into the design. The challenge is flowing 400,000 cubic feet per minute of air through a salt environment and keeping people out of the ventilation airstream downstream from the rooms, and then being able to provide an engineered control in that environment when there aren't any people down there. So we didn't ask for enough money to build an elaborate control system, but we did ask for enough money to build what I would call a supplemental control system. So I don't know that we can prevent the same thing from happening again in the future, but we can reduce its impact. So the downtime we think would be less if it were to occur again.
JR, you show a potential contamination area. Could you explain that to us a little bit?
Potential contamination area,
The turquoise.
this part right here,
Yeah.
it just hasn't been determined yet because of concerns about the roof bolt situation in that area of the mine.
Okay.
They got to take care of that first before we can complete those surveys. So the spot right before it has roof bolt issues So they know what the contamination is, where the roof bolts need to be applied, but we're not going to let people in past that point until new roof bolts are installed.
Would part of it be because that was potentially the primary flow of the air that came out and then went out there?
Yeah, I really don't know what the geologists have determined about that portion of the mine. I haven't heard anything on that. I'm sure they're doing an analysis on it, though.
JR,
Yes,
on panel 6, were there any of those Los Alamos drums? That
Yes.
Back end?
Yes.
Are you looking at those also, or are you just going to try to close that up?
we're just going to close it up. We know where they're at. We know how many there are, but we're not planning to go in with the reach system for that panel. We're just going to close it up and move on. So, moving on with the recovery operation, we have, like I said, resumed roof bolting. We prioritize the areas that need to be bolted first, and we'll basically cover those in the order of importance. The waste hoist, which is our primary system for people and equipment, is back in operation. Although it's not in full operation, it is available for emergency egress, so we can put more people down in the mine, which has been one of our limitations. And that's just been in the last couple of days. Again, I talked about fixing the contamination in many portions of the mine that we want to reuse. And so some of those methods have been tested in a laboratory, and we're going to do some real testing in the repository when we can get back into getting more people down there. So here's a picture of one of those bulkheads. It's a big stainless steel wall with steel I-beams and a rubber seal that's all the way around it. And sometimes we install these with louvers so we can control the airflow if we want to control airflow. But this is an example of one that would be used for closure. So it wouldn't have any airflow louvers. It's just intended to seal off that portion of the mine. I talked a little bit already about the ventilation system. We are wanting, right now we're operating at 60,000 cubic feet per minute through a filter bank, and that's limiting our operation down in the mine. Normally we would have had 425,000 cubic feet per minute when we didn't have contamination and we were using the full fans. So the next thing we want to get to in the recovery plan is interim ventilation, where we can have about 114,000 cubic feet per minute of airflow. We can use more equipment, have more people, be able to do more things in the mine. And then we'll get to the supplemental ventilation system and get up to 180,000 cubic feet per minute of airflow, and also have it segregated so that we have fresh air staying in the clean portions of the mine, and good airflow in the contaminated portions. And then the long-term plan, as you heard, is to get back to a new ventilation system. It's a capital line item project to add a new ventilation system on the surface and bring that and connect that to a new exhaust ventilation shaft so that we can have a clean exhaust circuit in the mine for getting back into normal operations for the future.
At what point could you start accepting waste again? Phase 2 or phase 3?
Phase 2 right now is our plan to start accepting waste on a limited basis in the first quarter of calendar year 2016. And then somewhere around the end of 2017, if the funding goes through and the design doesn't change, we hope to have phase 3 in place so that we can get back into full operation.
So that's your best case scenario is 2016, JR?
It is our best-case scenario
What's your
right now.
worst-case scenario?
It's going to slip in series with delays in funding, concerns about designs of the systems that have to be installed. Any number of factors could influence that. Could be a couple more years.
So the reason I'm asking these questions is because we would like your advice too. One of our committees, we're looking at writing a recommendation to provide, to bring the storage operational program going back here at Lanel, maybe other sites, but staging that waste to where once you're operational, then it's a quicker transfer, if you will. So we don't, I think some of us feel that we would be premature in bringing this back up because it came up in the summertime or a couple months ago and we were supposed to rewrite the recommendation. But we've got a little bit of cold feet because we want a better picture, better projection, you know, absolutely with your feedback as well to see when might be a good time to possibly start initiating this process to see if we can get staging going and move forward.
Well, most TRU sites are continuing with their waste certification activities and are planning to store on site as much as possible. Idaho is an example. They're going to probably build a couple more buildings so that they can store their waste so that they can keep certifying. Because if they just stop certifying and they completely shut down their operations, they won't meet their consent agreements that are coming up in 15 and 18.
And I appreciate that there's an economy. We already are facing some folks who've lost jobs, and that is unfortunate. I appreciate that, but we just want a better timeline. And then, because some of our concern is, if we start doing it anytime relatively soon, it's still above ground storage.
It is, and we only want that to be a temporary solution. The right solution for the long term is disposal in a deep geologic repository, and so we're going to get it back into the operation as soon as we can safely. And so our projections are what they are today, and they'll mature as time goes on. My recommendation would be to plan to certify and store waste as much as possible, because when we do get back into operation, hopefully there will be plenty of it in storage, and we can keep them trucks rolling, and we can get it down to WIPP and get it out of the environment.
I think one of the questions related to that was whether it would be more efficient to at least increase the storage at WIPP, because the transportation was presented as one of the limiting factors. That is, you could move waste from the surface at WIPP underground faster than you could truck it in from off-site locations. And so that in terms of helping these sites deal with their state regulators primarily, that storing it at WIPP, once WIPP opened, you could get it down a lot faster than you could if you had to start bringing it in from around the country.
Adding additional surface storage at WIPP is definitely something that we've evaluated. And at this point, because we're focused on recovering the repository, we don't want to let that get in the way or distract us, but it is something that we have evaluated, and we're going to continue to evaluate for what the timing of that should be if necessary.
With that in mind, what is your capacity right now? Are you near capacity, or is there room?
Our storage capacity on the surface at WIPP is near capacity.
Okay.
It's very limited size. Its only intent was to take what was come through in a normal, weekly flow, about a week's worth of contact handle and remote handle waste. It wasn't intended to store for any extended period. So we would have to build separate facilities on the surface designed for containing anything in the event of an accident in order to accommodate any substantial receipt and storage on site. And those would be capital projects, and so they're just not currently in our plans. We are focused on recovering the repository and getting back into business.
So then my next question is for Mr. Bishop. Mr. Chair, Mr. Bishop, so we're sending drums now to Texas, or we were, where are we?
So it's an interim measure once the truck fire occurred and prior to understanding that it was a lannel drum that breached underground, we had continued to ship to Texas for interim storage.
So that's interim, maybe that might be the resolve right now, because then we would then take what we have in interim and then take it to WIPP once it's operational, correct?
Yeah, there is no intention, there's no permitting or licensing allowing for disposal at the Texas facility of the waste control specialist. It's only an interim storage under their Texas agreement state license.
Thank you, and you've explained that before, just for some of the new members and just for some of the public, just try to get them up to speed on that. Thank you.
Exactly, that's why I'm trying to
Thank
give you a more complete answer.
Thank you.
Yes.
So, to refresh my memory, how many panels have been sealed already?
Let me answer that in two ways. There is waste in the first 6 panels, these dark colored ones.
Okay.
There is a small portion of waste here in panel 7. They've not all officially been closed. We were in the process of closing a couple of them, but they are sealed off from the ventilation circuit. So they have their short-term closure, but they don't have their long-term closures in some of the panels.
So then, what measure would need to be taken for the long-term closure then?
Take panel 6, for example. I talked about it. It needs the more extensive closure system installed, which is a combination of Bradis cloth, which is like a fiberglass cloth, from floor to ceiling, wall to wall, metal bulkheads, and run-of-the-mill salt all the way to the top. And so that's something that's also a priority for us because the state has asked us to expedite that for panel 6 and for room 7 of panel 7. That's going to be high on our list. We've already actually started the prep work for that.
Okay, so then JR, regarding that, and forgive me for my ignorance, so I mean, who would give final blessing as to the actual, like, if you will, sealing of those additional panels?
Well, there's actually 2 approvals that we have to obtain. The New Mexico Environment Department has to certify the completeness of the hazardous waste management unit, which is a panel.
Okay.
And they do that as we fill them up and we ask them to come and certify that.
Okay.
The EPA, who's responsible for the long-term performance of the repository, has to approve the method and has to also agree to the final method that's used and agree that it was installed properly. That's the part that we had not completed on some of the panels, and so we were going through that process with the EPA when all this occurred also.
Okay.
Where we have a new panel closure design to meet their specifications that had been proposed and had not been promulgated yet.
Okay. JR, I'm gonna play devil's advocate here. As of Friday of last week, it's been 9 months since that barrel ruptured, or that drum, I should say. It would seem that that panel would be closed off, sealed, and we would just move on.
So your concern is the amount of time that it's taken to get to this point?
Correct.
Well, we would like for you to understand that for the first couple of months after the incident, we didn't have anybody going into the mine. We didn't know what we had. And so a lot of that was very cautious, very limited mine entries to determine what went on. We sent our mine rescue teams underground with scientists to try to determine what went on. They would get suited up. They would wear respirators. They could only travel so far. They had to measure the contamination as they went. So the thing was full of unknowns, and there's still some unknowns. But we've mapped out the repository to the point now where we can go pretty regularly to and from, but it's still a limited operation. Because our safety basis was put into question, we've had to come up with an interim safety basis. And so everything that we do has to be pre-planned, has to be mocked up, has to be done by procedure, has to be done by approved work order, has to be as safe as possible, as clean as possible. And if there's anywhere along the way, any one person doesn't feel comfortable, we back out of it.
Sure.
So we've been doing that for 9 months. We've been trying to figure out how to do that the appropriate way, but in a more efficient way. And we're getting better at it, but that takes a lot of time,
Sure. No, yeah,
especially not knowing what you had.
correct. I get that, Jared. Just, and the board here, they know how I feel about this. I mean, to me, it's an anomaly. One single drum rupture and it hasn't occurred. And it may never occur again, hopefully, but anyway, I'm going to stop rambling now. Thank you, JR.
All righty, thank you. Hopefully y'all also can appreciate that both for Los Alamos and for Carlsbad, that since these have occurred, a lot of people have paid a little bit closer attention to us that probably normally wouldn't have, and so we're being scrutinized heavily in everything that we do, and rightfully so. We're accountable to the public, and we don't have a problem with that. But at the same time, we can't just go back to business as usual. Things have to change in order for us to be able to do this right and provide that accountability to the public. So we want them to have confidence that when we do go back into operation, first, hopefully nothing like this will ever happen again, but if it does, that we're prepared to deal with it. And so that's where we're headed. And it's going to be slow, it's going to be tedious. We wish it had been moving trucks a couple of months ago, but we're just not there yet. So we've gone through a lot of training, a lot of culture changes, and before I wrap it up, I also want to mention a couple of things about the finalization of the action investigation report and what kind of actions that might come out of that might be. We've seen some preliminary language from the draft report, and it's given us an indication that we're going to need to have some corrective actions in the area of certifying waste for WIPP disposal. We're going to have to, well, what I would say, dig a little deeper into the information that's provided especially in an area called acceptable knowledge for waste characterization. And so we're going to go ahead and start that process. We're going to go through some additional assessments at each one of the sites, and we're asking each of the sites to do their own assessments to increase the pedigree of the information that's obtained about not only how a waste stream was produced, but what's happened to that waste stream ever since it's been produced, especially if it had a characteristic that prohibited it from being certified for WIPP disposal and it had to be reworked in any way. We're going to focus on those. We're going to increase the risk mitigation factors that go into that to reduce the risk in accepting a waste form that wouldn't be acceptable for disposal at WIPP in the future. We're not going to be able to guarantee that it won't ever happen again, but we will guarantee that we're going to do everything we can to prevent it and to be prepared to deal with it if it does happen.